Hi, I'm Phil, and today I'm going to unbox the Eisco Physics Starter Kit. Now, this comes at a discounted price of around about $300. Quite expensive originally, but the downside is that it comes unlabeled with no instructions. I've added all these labels to identify the components, and it's my aim to make some instructions for it, but also to complement it with modern STEM devices, like the adding a microbit computer. So here's a microbit computer that can work with the Physics Starter Kit, and this one is self-contained. It has an accelerometer, a magnetometer, can detect temperature, and is an excellent addition for physics experiments. For example, the Eisco Starter Kit comes with a Hall's cart, but no incline plane. So I'm now getting that as an extra, and the microbit fits inside the Hall's cart. So you put this on an inclined plane, and you can do all sorts of experiments in physics with that combination. Now, some of the other devices that you get a Slinky Coil. So I've never done any experiments with that, but you can use this for doing experiments in both traditional physics, energy conservation, and momentum, and get it to move down the stairs, so it can be used for a bit of entertainment too. But it's also used for wave propagation, both longitudinal and transverse waves. Some of the other devices, it comes with a spring coil and a Newton meter, so you can measure masses the old traditional way. Put that on the retort stand that comes with the kit, and you just add masses, and there are masses that come with the kit, so you can just add those. Or alternatively, you can do experiments with Hooke's law. So you just add, they provide all sorts of springs, and you can just add those and just see how far it extends. And you can start straight away doing these experiments with Hooke's law. So you've got that one, and you can. It even has a indicator, so you can do experiments that show you what it's like to add additional weights. So in addition to Hooke's law, you can do Boyles Law, and it comes with some blocks. 2 blocks and a syringe, and the idea is that you put the syringe in here, and you can then use your pressure, your hands, and compress the volume in the syringe, and you can then measure and see what the relationship between the pressure is and the volume. So I've yet to do that experiment. Some of the other things that are contained, there's simple electric circuits, and it comes with a box of circuits, components. So I'm just unwrapping those now just to show you what's inside. So there's some wire, there's light bulbs, and some more wire, and clips with carbon conductors. So there's a few components there, and they all fit into a baseboard, which has an old traditional knife switch. So this is actually quite old, and it really needs to be upgraded. But in addition to electricity, it can also do magnetism. So if we put these ones aside, you get the traditional magnets, and you get iron filings. So the iron filings are contained in here. So you get iron filings, but you also get an indicator for magnetism, and you can put magnets on that and you can see the impact of the magnetic fields. You can visualize that quite quickly. So not bad as an introduction for magnetism. There's a cup here with a spout on top, and that's a displacement vessel for buoyancy measurements. So you can do that in addition to the Newton meter, and find out how much displacement there is when you put objects into a fluid like water. So you also get some pulleys. You get a suction caps, and you can do experiments in optics. So you get a light box, and it has a slit, and you can put various optical devices. So there's a kit here. So I'm just taking out the optics kit, and in the optics kit you get various lenses. So the idea would be to take one of these lenses, switch on the light box, and you can then reduce that to a single slit. So you can see the slit there, and that's used to look at the propagation of light in various lenses for optic studies. These are some of the other components that allow you to do Hooke's Law, Boyles Law, and explore Archimedes Principle. So if we just open up these, you can see there are various weights, and there's no need to there's no measurement here of the weight of the object, but you would probably need a electronic scale. So these are all the same size. This one's brass, we've got aluminium, and we've got zinc. So you've got different weights, and for Hooke's Law you've got different springs, so they'll have different impacts on the experiment. And that's about it. There's a lot to do, and it should be interesting to put it all together. And that's it for now. Bye from Philip.